Hi, welcome to Ben's Kitchen, where we're making a geothermal power plant, and it's really simple, nice DIY, and here are the things that you're going to need.
Alright, so you're going to need a pot, preferably one that can hold water in it, a permanent marker, a can of your choice, we chose beans, a pinwheel, we have a lot of selections here, safety goggles because you always got to be prepared, and a hammer. You also need some tin foil and a nail. All right, so what we've just done is we've taken the hammer and the nail and we have put two holes as directly across from each other as possible in this can. You want it to be approximately 1/8 inch in diameter. So that's what we did. Okay, so now we're gonna take the can, we're gonna take a ruler, and we're gonna attach it onto the can with rubber bands. Beautiful.
Yeah.
We added a few more.
Now you're going to take your pot and fill it just over halfway with fresh tap water. It's gonna take a few seconds to let's say that's good. You're gonna bring it over to your stove.
So you're just going to take foil about the, large enough to cover up the top of the pot. Get a nice little tear, you know what I'm saying? Maybe, if I don't, just like so. Now, you take it, you're going to want to cover the pot as complete as possible. Now when this heats up, it should be modeling the earth. It's the geothermal part of the geothermal experiment that we're completing. Now to ensure maximum efficiency, we're going to take a duplicate piece of tin foil, the exact same size as before, tear it with just as much turmoil and struggle as the last time, with no extra practice. Go right over the thing, you know what I'm saying? Right over the last piece. Now, we need to make sure we crimp it so no steam will escape. Absolutely none. Negative amounts of steam shall escape. See, it's crucial. Make sure it's high crimped around the lip so there would be no escaping gas, so we may utilize all the heat distributed throughout the process of heating a bucket of water.
Okay, so next you're gonna take your nail and we're gonna go to the center of the aluminum foil. And what we're gonna wanna do is just poke it through both layers of the foil. All right, so there's our hole. So now what we're gonna do is we're gonna turn this to medium high. The reason for this, the reason we don't just turn it all the way up to boil as fast as possible is because we don't want any of this water hitting the foil at the top and messing up our results. So we're gonna go ahead and take this, we're gonna light it. All right, we got medium to medium high, so we're gonna go right there. And this water will boil until it is at a universal temperature of 100 degrees Celsius. It'll be at a rolling boil at that point, and we'll come back when we are there. All right, so what we have happening right now is we have our pot. It's been boiling for about 5 or 10 minutes now, and this represents the power plant gathering energy from the earth. Okay, so what we've got now is this is coming to a boil. We can hear it, we can see the steam. You might be able to see the steam coming out. If we get a closer look right here, you can see that steam coming right off the top there, out of the energy hole. So now what we're gonna do you have the 30-second timer up?
Oh yes, sir.
All right, as soon as I place this on, we're gonna begin a timer of 30 seconds to keep our results consistent, and then we're gonna demonstrate the power of thermal energy.
Timer is started.
Now we'll just wait here for a while. And what we're gonna do whenever this hits 30 is we're gonna hold this over it, and it should spin a little bit.
Just rotate that. Just a little something.
All right, just stop. Stop.
Don't. It's hot, Ben. It's a can.
All right, so we're about to hit 30 seconds. All right. And now.
All right, we can stop it. Now, if you say, oh,
You can see it beginning to spin magically. The power of thermal energy
snap.
is unimaginably
Imagining.
good.
Oh,
This is why
snap.
steam has been used as one of the primary power sources for centuries. Over a century.
Oh, snap.
This is doing much better than expected, I would say.
Ooh.
I think we can power my house with this now. Alright, so we're going to show now that the amount of resistance you have on these pinwheels really affects how well it spins, because this is a much heavier pinwheel, and this one has a wooden axle, which makes more friction between the pinwheel and the axle, which makes it a lot harder to spin. So we've had this on here for about 30 seconds now. We're going to put it over and we'll show that it does not spin from this. And here you can hold this one now. And now we'll do this one. Not sure about this one, honestly. It's gonna be interesting. Oh, we got a little bit of spin. We're gonna try this one.
Yep.
So see, you can see that spin doesn't generate from this one, but if we bring back our other pinwheel, instant power. And look, as we raise it away, it actually gets faster because it touches more of the surface area of the pinwheel's rotors. All right, so we're gonna do a quick recap of what we've learned today. So we learned that thermal energy is able to convert matter into different states. And we've also seen how this results in the generation of energy. And we've seen why steam power is one of the most widely used sources of power. So remember what this is a model geothermal power plant. We have the boiling pot of water, which is the earth in this case, and then the can with the ruler attached to keep it stable is the power plant. And as the steam collects in the power plant and gets condensed, we're able to stream it out into a direct contact onto the pinwheel, and the energy moves the pinwheel. Anything to add? We hope you enjoyed this production. Thanks for watching.
Yeah.
Now we are going to show how thermal energy can be harnessed from the sun using a magnifying glass and turned into work in the form of fire or near fire on a piece of paper. The tricky part is getting the angle exactly right because you have to line it up with where the sun's coming from. But we'll see what we can do here. All right, so here, we'll flip it over to show the realisticness of this, all right? So I'm gonna line it up so that circle's as round as possible. Now we're gonna zoom in. You see smoke. See it just burning away. Now take a look at that damage we've done. You can also do this with plastic water bottles
All right,
filled
now
with
put your
water.
foot under there.
All right, now we're gonna try doing it on human skin.